Hello guys, today we are going to do this multiple choice questions, and this question is which of the following integral diverges, and pick one answer only. You see the diverges has a S here, so only one answer, So how can we do this? You can see four of this integral, they are really similar because they are all some special constant raised to negative x power from 0 to infinity. So we know that integral are really common integral from 0 to infinity of e to the power of negative x is actually converges, because when you integrate you get e to the power of negative x, and then divided by negative 1, so negative here, and then e farther away from 0 to infinity, and then put infinity here. E to the power of infinity is goes to 0, so you can get 0, and then minus negative, so you can get plus e to the power of negative 0, so this 1, so you can get the answer is 1. So how can we integrate a constant? You can see four of these integrals are all constant raised to a negative power. Do they are similar to the integral of e to the power of negative x also converges as well? No, because since these four integrals, they are constant raised to negative x power, so let me try to figure out what's the integral of a power of negative x dx from 0 to infinity. So a is for constant. A is a constant. So I think this a should be greater than 0, I think. Greater than 0. I think 0 is okay. But when you plus 0, 0 power of 0 pretty much just diverges. But I think it's still. I think a can be equal to 0. I think because 0 power of anything there is greater than 0. There are greater than 0. It's just 0. But let me just stop. So how to integrate a constant rate to a negative number? So let me talk about how to differentiate a power of x, a constant raised to x. So you pretty much just write it as derivative of e power of ln a power of x. E and ln, they pretty much just cancel out, so you can get the derivative of e power of, put the x in front of the ln, so you can get x times ln a. So differentiate this first, you can get differentiate e power of something, just keep this. So keep this and then differentiate this. So you can get differentiate this ln a is just a constant. So ln a. And then here you can just put a x inside the ln once again. So e and ln they can cancel each other. So you can get our a power of x times ln a. So we have a negative x here, pretty much just similar. They are pretty much similar, just you will have a negative sign here. And then when you integrate this, you get a power of negative x, right? And then you are going to divide it by negative 1. So when you differentiate a power of x, you get a power of x ln a. So you have to 1 over that, right? 1 over ln a, 1 over the constants to cancel the ln a. So this is the reciprocal of derivative. It's kind of like, so you farther away from 0 to infinity, like that. So when you farther away, so put infinity inside it, you pretty much just use the limit when x approaches to infinity, and then a power of negative x, you can write this as 1 over a power of x. So we assume that a is greater than 0. So when x approaches to infinity, pretty much just 1 divided by are extremely big numbers. So you pretty much just get. However, though, I think this A only for. I think maybe for 1. I think 1 also diverges as well. You see why? This A should be greater than 1 here, because when you take the limit at x approaches to infinity, let me talk about the good. So when A is greater than 1, you pretty much just get a really big number increasing and then to infinity, right? So for example, like 2 power of an extremely big number goes to infinity. So 1 divided by infinity, you pretty much just get 0 here. So however, when you take the limit at x approaches to infinity, 1 over a power of x, when this number a is between 0 and 1, you will see what happens. So 1 over a power of x. So for example, if a is like 0.5 here, 0.5x, like that. So you can write this as our limit at x power of infinity 1 over 2 in the power of x, right? So you can just distribute. So 1 power of x pretty much just 1, and then 2 power of x, you can write this as this, and then 1 divided by that, you pretty much just get, this is 2 power of negative x, 1 over that. Once again, you pretty much just get limit as x approaches to infinity, and then 2 power of x. So when x is approaches to infinity, so wait a second. So when x is approaches to infinity, 2 power of infinity pretty much just infinity. So this integral converges only when a is greater than 1 here. So if a is equal to 1, you pretty much just get 1 power. I think also converges, but 1, no, it doesn't converges, because when a is equal to 1, integrate 1 from 0 to infinity, you pretty much just get the graph of 1 is like this, and the integrate this from 0 to infinity, pretty much just infinity. The area is infinity, so this diverges. So only when a is greater than 1, and then this limit is equal to 0. Put infinity here, you get 0. And then minus this, and then plus. Remember, you should put a 0 inside the x here and not the a. Don't make the mistakes. And then a power of 0 here. When a is greater than 1, you pretty much just get 1. So over you get 1 over L and A. So your answers pretty much just get 1 over L and A. So you assume that this A should be greater than 1 here. So how can we do this? So what is gamma here? And gamma, this means the Arrhenius-Mastroiannis constant here. So Arrhenius-Mastroiannis constant is about 0.577. I remember. And then so the value of a is just between 0 and 1. So this integral pretty much just diverges. And sorry guys, it should be converges. So converges. So not diverges here, because you have 3 answers if you say diverges here. So only one integral, only one option is a convergent integral. So this gamma is between 0 and 1, so this pretty much just diverges. So cross out this option. So integrate from 0 to infinity, and then g power of negative x. And g pretty much just the Catalan constant here. You can also use the c. So g is about 0.91a. It's about this value. So this number is also between 0 and 1. So this integral diverges as well. So what about the golden ratio? This is our golden ratio, which is 1 plus square root of 5 over 2. Let me use our calculator. It's about 1.62 here. So this number is greater than 1. So we can see this pretty much just converges. So the option is just C. But we should also check if D is converges or not. So over L12 is just L12 is about 0.9693. So overall, this number is between 0 and 1. So overall, this integral converges. So the only converges integral is integral from 0 to infinity, and then the golden ratio power of negative x. So only this option is taken. So you can also use this formula to get the result of this integral is equal to 1 over L1 golden ratio. So it's really cool.